Hey guys, welcome into the Wells Tech Garage for our Toyota EVAP. Oh, hang on one second, let me turn that sound off. Hey, I think we should be good now. Beautiful. Okay, I'm back. All right, so feels like it's been forever since I've been up here in front of you guys. Last class was the beginning of June, and we're now the second week in July. I hope everybody had a nice holiday last week for those of you that are in the U.S. All right, so today we are talking Toyota EVAP systems, and as many of you probably are aware, Toyota are kind of touted as the most complicated EVAP system out there, just because of a lot of different parts and pieces. I mean, look at this thing. This is the canister assembly. This is the canister that would go on the 06 Avalon that's sitting here behind me. And then this, see if I can put this back on here without it falling off the table. This here is the canister assembly for our 97 Camry sitting right here. So there's a lot of pieces and parts to these things. I'm going to show you guys how they work, how to diagnose them, what to expect when you get them in your shop. So I got a lot of stuff that I'm going to throw at you guys today, so I hope everybody's got their thinking caps on, or at least their feet up and ready to learn. Like I was chatting with you guys in the beginning there, it's a good thing that this is then a recorded video afterwards, so if you missed it live or if there's stuff you want to go back and see, definitely check it out again. Okay, so before we get into the class, we have a couple things to go over first, some little announcements. Let's start with what you guys are probably all anticipating to hear. Who was the winner of the Wells Tech work shirt? Remember, we did the survey, and I said that whoever answers the survey will be randomly drawn to win one of these work shirts. So over 200 of you guys did the survey, and I picked a random winner. That random winner is, drum roll, Robert Champagne, or Champagne, or however you happen to pronounce it. Robert from Texas, you are the winner of the Wells Tech shirt. So go ahead and bring up my email address. I need you to shoot me out an email with the shirt size that you want, and then that's Fritz's email. Let's swap that over to my email real quick. That's okay. Sorry guys, let's get the right email up there so that way Fritz doesn't get it and is all confused. All right. So Robert, send me out an email with the size of this thing that you want, and then we're going to stitch in your name. So if you want Robert on here, or Bob, or Peter, or Al, or whatever name you want in it, I don't care. We'll have it put on the shirt as long as it's not a profanity of some kind, okay? So Robert, congratulations on winning. You will be able to wear this thing proudly because you are going to be the only other person out there that has one of these shirts besides us in this room right now. So awesome, congratulations. I'd love it if you could send me a picture out once you get this thing. Okay, also, we have another little giveaway besides our t-shirt giveaway. In my hand right here is our next giveaway. And the reason why you don't see anything, this is 3 $50 Amazon gift cards. And I'm giving these gift cards away to anybody that shows up to Auto Mechanica, wears one of our shirts, and then is caught by me, or you meet up with me and we take a picture together. You will be entered in to win one of those gift cards. So anybody going to Auto Mechanica at the end of the month, the 27th, 28th, and 29th, I'll be there all 3 days. If you wear a Wells Tech shirt and you text me or call me or something and we meet up, get a selfie with you in the Wells Tech shirt, you will be entered in to win a $50 Amazon gift card that I will be giving away each of the 3 days. Okay? If you are looking for my contact information, please send me out an email. If we can bring that up on the screen one more time. Shoot me out an email with what days you're going, what classes you're going to. Maybe we'll be in the same class, that kind of thing. And then I'll shoot you out what classes I will be in. I'm not actually going to be teaching there. I will be just attending as a participant. This will be my first trip to Auto Mechanica, so we'll see how it goes. But I'm hoping to meet some of you guys who are going. So $50 Amazon gift cards for each of the 3 days. Wear your Wells Tech shirt, meet up with me, take a picture, and you're entered. Okay, super simple. All right. Well, let's get right into this. We are covering EVAP-2 today. We are going over Toyota and Lexus EVAP systems, okay? Up on the screen, is our Wells Tech question. This one's going to be tricky. We'll see what happens here. A newer vehicle is failing emissions for a very small leak code. This will be like a 20,000th leak code. Its PCM uses the engine off natural vacuum leak detection for this test, which is what we talked about last week with last month with our escape if it had California emissions. Of course, it is July 13th today, and his registration is due on the 14th. As a temporary, quick, easy repair, a technician siphons the fuel out of his plow truck into the newer car, runs the monitor, and passes his emissions test. Okay? Passes the small leak code after he runs the monitor with that siphoned fuel from his plow truck. Why? Why has this thing now passed emissions, okay? And hint, guys, it was not the gas cap being loose initially and then he tightened it down after he siphoned the fuel, okay? Not a gas cap. If you answer gas cap, it's wrong, okay? There's your hint. Email me at my email address up on the screen there, or it's been up a couple times already, for your chance to win. And again, you get to win either a Wells hat, gray, black, or blue Wells Tech t-shirts, okay? So this question is only valid for today, July 13th. And you have until the end of the day to send me out that email with your answer to the question, okay? And don't feel like you have to answer it at this exact moment. You can always go back, pause the video with it up on the screen, think about it for a little bit, and send me out an answer. Okay, so I think we have all of our little news bulletins done here. Let's get right into this. All right, our Toyota EVAP systems. As you can see, the screen is pretty full right now. Toyota has done a couple of different things over the years. When they started out, we were seeing from 96 to 99, the non-intrusive split purge seal system, which is what, what this Camry has here behind us. Then they went into an intrusive split purge seal system. Then they went to a standard purge seal system, which is going to be just like the system that we talked about last month. So I'm not going to spend any time on the LEV 2 system, just because of the fact that we've already pretty much gone over the purge and vent solenoid type of systems. We're going to then spend some time on the leak detection pump system, which is 04 to present. That is our 06 Avalon behind me. And then I'm going to just briefly touch on the bladder style system that we find in the Toyota Prius. Note, guys, service info is your friend here. Make sure you know what kind of system you're diagnosing before you dive into this thing, because every one is going to operate a little bit differently and you're going to test them differently, okay? And also be careful when you're looking at your pressure reading PIDs on your scan tools. They can be written in either gauge pressure or absolute pressure, and then the different scan tools or different makes and models, different models of Toyotas might be giving you different PID information, okay? So always look at your scan tool PID. You might have to run it through a converter or that kind of thing just to get your information down. All right, so the similarities between all the systems, all the Toyota systems do have some similarities. They all have the same goal, of course. They're an EVAP system. They want to trap and burn those fuel vapors. All the systems use a fuel tank pressure sensor. They all have a purge solenoid. They all have a vapor canister. And for all of them, fuel level is very important, along with intake air temp. That way the computer kind of knows how many vapors it should expect inside of the fuel tank, okay? Acronyms. These are the tricky, it seems like everything on a Toyota is called a VSV. A VSV stands for a vacuum switching valve. If you see EVAP VSV, that is going to mean the purge solenoid. CCV is canister close valve. That is going to be our vent solenoid on some of the systems. They don't all have vent solenoids. VPS is the vapor pressure sensor. That is the same thing that we're used to with a fuel tank pressure sensor, just a 3-wire standard map sensor / fuel tank pressure sensor style. And then we have our VP VSV, or the bypass VSV. This is going to be our bypass valve, which I'm going to be getting into in just a second here. All right, so the non-intrusive split system, we're running, again, 96 to the 99, roughly, cars, trucks, and Lexuses. The canister and system location is going to vary on vehicles. A lot of them will have the entire unit mounted under the vehicle, back by the gas tank. Actually, on our 97 Camry here, we actually, this is the 4-cylinder as well, 2.2 liter, I believe. It is mounted under the hood, right up by the airbox. I'll show you guys that in just a few minutes. So the non-intrusive split system is a system that is passive and does not do anything to manipulate its pressure or vacuum in the system, hence the non-intrusive wording. This system is unique in that it is sealed at all times. Okay, this is unique to EVAP, guys. We're used to a wide open vent solenoid allowing our system to breathe in fresh air or breathe out that filtered air. This system is going to be sealed at all times unless there's an overpressurization or an over vacuum issue inside of the system, or if it's really hot out that day and there's a lot of fumes being generated. There are some mechanical, let's call them blow-off valves or pressure relief or vacuum relief valves that are going to go off at roughly the 5 inches of water mark. Right here's the spec on that, okay? So in a normal system, with this thing sitting in here, it is supposed to not be at atmospheric pressure inside of the tank, okay? That's really important to keep in mind as we get into this system, all right? This system also uses natural vacuum or pressure generation from our gassing or condensing fumes, fuel fumes. There is no vent solenoid or CCV on this system. And the reason why it is called a split system is because the PCM is going to test each half of the system, either the tank half or the canister half, separately. They are their own entities, and I will get into that when we actually demo it over on the fuel tank setup over there. While this vehicle is parked, we should be building pressure if it's warm, right? If we're going to go through a hot soak, we should see a pressure increase inside of the tank. If you're parked on hot blacktop, something like that, you'll see pressure increase. As this thing sits and it cools down, you should see vacuum begin to increase. If the fuel tank pressure sensor, VPS, is reading atmospheric, there is a leak in the system. So this is huge, this line right here, guys. If you hook up your scan tool and you're reading atmospheric pressure on the data PID, you have an issue, right? This system is not able to pull into a vacuum or a pressure because there's a leak in the system. This thing should not read atmospheric after the vehicle's been sitting. Again, your scan tool data can trick you on this. Be careful. Uh-oh. Okay, we're back. Atmospheric pressure can come across on our scan tool a couple of different ways. Be careful. You could see it as 0 or 762 millimeters of Hg. You could see it as 0 psi. You could see it in inches of water. You could see it a lot of different ways. Basically, we need to just understand what we're going to look for. We're looking for anything to not be 0 or not be 762 millimeters of Hg. So if we want to just do a real quick and easy rule of thumb, if it says 762 millimeters of Hg, that is going to be equivalent to 0, okay? Anything higher than 762 is going to be pressure in the tank. Anything lower than 762 is going to be vacuum in the tank, okay? Just as an example, with the two scan tools that we have here, the Snap-on Varus showed me millimeters of Hg inside of our tank, and that started at 0 and went negative for vacuum, positive for pressure. And the Launch scan tool, which we just recently got, I'll talk about in a second, showed me the same thing in PSI, starting at 0, going negative to positive, okay? So it depends on your scanner, depends on the model Toyota, but just know if it says 762 and the system is supposed to be sealed up at that point, you have an issue, right? It's reading atmospheric. There is a leak in the system. So this is what the system looks like on a drawing. This is the system diagram. Here's our vapor pressure sensor. This is our VPS, or our fuel tank pressure. And here's that bypass right here, the VSV or bypass. This is going to be our valve, or let's call it a gate or a door or whatever you want to call it. This is what's going to separate the canister side from in this dotted box right here, the fuel tank side. Okay, so we have our tank, a little mechanical valve on our canister that goes to this side of the fuel tank pressure sensor. And then we have the canister up to the purge solenoid, and then this mechanical valve over here that goes to the other side of our pressure sensor, of our bypass, excuse me. And then when the bypass is in either one direction or the other, they will be testing then the pressure on the system, okay? So in normal operation, let's call it normal, we'll say key on, engine off. This system will be connected the canister side to the fuel tank pressure sensor. So flow will go like this up into there. When the key is turned on this system, the computer goes ahead and grounds this bypass valve and keeps it grounded, therefore turning it on, and then we are using the vapor pressure sensor to measure the fuel tank side of this thing, okay? So key off, you should expect to see the system will be connected to the vapor pressure sensor. Now it's important when you turn the key off, you're not going to have your power and ground to this vapor pressure sensor, so you're not going to be able to get a reading anyway. But that's the way this valve is going to work, okay? If you were to switch this valve off or go ahead open up the connection or something like that, then the valve would go open and we would be reading canister side. So we'll do that with the scan tool in just a little bit here. So this system seems very, very complicated just from a quick look here. There's a lot of stuff on the screen that's going to be moving or doing something. But in our wiring diagram, you can tell that we aren't nearly as complicated, which tells me that this system has many mechanical or mechanical components to it. So we have our vapor pressure sensor, our fuel tank pressure sensor, whatever you want to call it, 5 volts in on our yellow wire, signal on our pink wire, and ground on our brown wire, all going back to the PCM. Super simple, that's what we're expecting to see. And then it looks like we have some power flowing into our EFI main relay, which sends power to a junction, which sends power to our VSV for EVAP, which is our purge, and then also our VSV for vapor pressure sensor, which is our bypass, are both supplied power on the same wire through this junction right here, and then they are ground side controlled by the PCM. Okay, so if you're missing power to either your purge solenoid or your bypass solenoid, check your fuses, check your wiring somewhere there, and then ground siding controlling the bypass and purge solenoid. You should be able to do that with a scan tool, or you could go ahead and jump that thing to ground and do the work of the scan tool. Okay, so this is what a brand new canister would look like. This is what is on this 97 Camry. This is it right here. And as you guys can see, it's not incredibly massive, but I did take it apart so we can get some shots of what it actually looks like. So this is just the canister part, just the box, and it's super, super simplistic. You can see those 2 ports in the center. That's all that it is. It is a box containing charcoal with 2 holes. Fuel vapors go in, fresh air comes out, right? Very, very simple. The actual canister itself, very simplistic. The part that does all the work, this part right here, which looks like this. All right, so that is the normal mounted side, and then this is obviously the underside of it since I took it off. So what does all of this do? All right, here we go. This hose right here connected to it goes to our purge solenoid, which obviously is connected to our intake manifold vacuum. And then we have this guy here is connected to our air box. We have a vacuum relief valve right here, so this acts as our vacuum relief valve. Then we have our pressure relief right here. Pressure is going to come out of this one. We have a port bag here. That's going to be going to our fuel tank. We have, and 2 hoses here going to this is our bypass solenoid right here. And then on this small little hose right here, that's going to run a hose out to our fuel tank pressure sensor. So when this thing is off, we are measuring pressure from our canister side through the solenoid to our fuel tank pressure sensor like so. Then when we turn this solenoid on, we are then connecting these 2 ports. So now we're going to measure tank side pressure or vacuum out to our fuel tank pressure sensor. Okay? And if we look at this thing in comparison to a diagram, you can see the numbering here. I'm not going to go through the entire thing. If you want to go back and watch this yourself, you can. But this is what how it's all going to work. These are the different points are labeled accordingly. All right, here is what it's going to look like if this system is purging. We take our vapors into the intake right through our purge. It's going to travel through this assembly down into our canister where we're going to be drawing fresh air in, right? You know, we can't draw the system down into a vacuum. We have to allow that fuel vapors that are being drawn into the motor, we have to allow something back in to take their place. So that's what this fresh air, call it our pressure relief, or excuse me, our vacuum relief valve is for. Now what's unique about this vacuum relief valve is, as this thing is sitting right here, this is acting as a relief valve with a diaphragm in there that is going to go off again at that like roughly 5 or so inches of water. So you cannot blow through it or draw vacuum on it until you overcome that, that diaphragm. So you can tell that there is a restriction in there until it overcomes the diaphragm. But when we apply vacuum onto this purge solenoid port right here, this applies vacuum to here, this little hose right here is connected to that vacuum internally behind the plastic here. That then draws this diaphragm up, allowing our vent path here, this one that's slightly restricted, it allows that vent path to open fully and create no restriction on there whatsoever. So we apply vacuum to this guy, allows us to breathe easy here, allowing air, fresh air to be coming into our canister as we're drawing all those fuel vapors out into the engine, okay? This note right here is very, very important, and I'll show you guys that in just a second. When we are purging on this system, purge does not draw vacuum on the fuel tank, only on the canister. And this is caused by one-way check valves inside of the canister assembly, okay? So if you are jumping your purge solenoid and you're trying to watch the fuel tank side of the system, you will not see a change, okay? That's very important to note because that could really throw you off. You know, with a standard purge seal system, you go ahead and you run the purge solenoid on, you close the vent, you draw the entire system down into vacuum. You cannot do that with this early design system. You can only draw the canister down to vacuum, okay? You will not draw vacuum on the fuel tank. But pressure to that purge port, you will send pressure through the entire system because you will be bypassing or forcing open one of those blow-off valves or pressure relief valves. So vacuum, only checking the canister. Pressure, you are checking the entire system, okay? All right, so before we get of this initial system, why don't we head over here and I'll show you guys exactly what all this means. So let me bring the camera with me, guys. All right, something like so. So here's the canister all hooked up. This canister is the same as this one. It's just one that is mounted underneath the vehicle, and it is also on a vehicle that would use onboard vapor recovery. This one does not have onboard vapor recovery. So for today's testing purposes, I have put a plug into the vapor recovery port on the canister. I have a purge solenoid hooked up to this thing. It is connected to our fuel tank. We have a sealed gas cap. We have our drain here, our air drain, which is going to be one of our pressure reliefs is the drain, which is what we were just talking about. And then we have our piece here that goes to our air filter, okay? So why don't we start by taking a peek at what this thing looks like on a voltmeter. Get this turned on, turn on our voltmeter, and let's take a look. Now right now, our solenoid is off, okay? Hopefully you guys can see that. Let's get a close-up shot of this. Should be able to see that for you guys. It's reading 3.6-ish volts, okay? Now what I'm going to do is I'm going to take the purge solenoid out of the loop. And basically the reason I'm taking it out of the loop, guys, is a purge solenoid is a purge solenoid. These are not going to be any different than what you guys are used to testing. It should be sealed up when it is unpowered, and when you power it up, you should be able to breathe right through that thing. So I'm taking the purge solenoid out of the loop just to take any sort of complication out of this. So what I'm going to do, first of all, is I'm going to go ahead and hook up a vacuum pump to our purge line. So what are we doing here? We're drawing vacuum just like our purge solenoid would on the system. So as you guys can see, we are drawing vacuum on the system. I'll go ahead and release it, and then draw it again. So we're drawing a nice vacuum on the system, but we can't get it very low, right? I can't get it any lower than that 1.9 mark. No matter how much I pump this thing, I will not be able to get it any lower. And that's because this guy right here, remember we have a vacuum release valve or a vacuum relief on this thing. So what I want to do if I want to draw this thing into even more vacuum, I need to plug that part that would go to our air filter. So there we go. I put a plug in there. Now watch. So if you guys are testing this thing and you want to test it with vacuum and you want to bring that vacuum really low on here, you're going to have to find a way to plug this hose, whether it's a vice grip like this, or a hose clamp tool, or a plug like I just put in here. You're going to have to find a way to plug that off in order to draw complete vacuum on the system. Now, I told you guys that we're not drawing vacuum on the entire system, right? We're only drawing it on the canister. Here's a gas cap. The tank is not under vacuum right now. Okay, let's take this one step further. So right now we know that our VPS, vapor pressure sensor, is reading the canister side, right? So what if we turn that on and read the, let's read the fuel tank side. So I got a little jumper wire here. I'm just jumping power to ground. You guys can probably hear it click. Okay, clicks. Now let's look at what our meter says. 3.7. All right, and 3.7 is atmospheric for this fuel tank pressure sensor. All right, because we have no, we have our gas cap off of this thing currently, so we are reading atmospheric pressure on here at 3.7 volts, okay? Now, I want you guys to see that we haven't taken this system and combined them together, okay? We haven't bled off our vacuum whatsoever. Our vacuum is still right where it should be, and here's the proof. I'm going to turn our vapor pressure switching valve, or our VSV. Again, the acronyms can get to you. We're going to take our bypass solenoid and turn it off. Let's watch our meter. Right back to that vacuum state inside of our canister. Switch and check the other side. We're under atmospheric. Now, if we apply pressure to this, all right, I'm going to turn on, I'm applying pressure into the tank. All right, I'm applying tank side with pressure. I'm just going to turn this guy on, and I'm going to close our cap. And I'm only going to do this for a second. You guys can, and I didn't even click the cap. All right, so I didn't even click the cap. We built pressure inside of the tank, but if we look at our, again, this is turned on, our bypass is turned on, so we're reading the tank side. If we go back to the canister side, you'll see that my value has changed. Right? It's come up in voltage now, and that's because when we smoke test this system, when we apply pressure to this system, it is going to force it past some of the check valves, and we will apply pressure to our canister. So let's watch. We're measuring canister side on our voltmeter right now, and I'm going to apply more pressure into this tank. In fact, I'm going to close the gas cap. Boy, those are some pretty sad-looking ducts in there. Boy. All right, so we'll apply pressure to this tank, and we'll see, and I don't know if you guys will be able to hear it, but I'm going to be able to hear the diaphragm being bypassed. You'll hear kind of a little vibration noise as it's bypassing, the pressure is bypassing the diaphragm. So turn this on, and we should see this voltage come up. And I don't know if you guys can hear, getting in the way, but I don't know if you guys can hear, but we bypass the diaphragm inside of there, and that's why we are building pressure on that side. All right, so now we look back at our tank side. Our voltage is still higher because that check valve has that range, right? That 5 inches of water range. So our pressure is still higher inside of our tank than it is on our canister side, even though we pressurized the system. Now let's go into the purge port. So I'm going to take our vacuum gauge off now. I'm going to bring our system back to atmospheric. So we're looking at the tank side and the purge side, or canister side. They're both the same right now because I have the purge solenoid open. Put the cap back on, and now instead of applying smoke into some erroneous port on the fuel tank, which you guys aren't going to have because you're not going to go and drill a hole in the fuel tank like I have here, I'm going to apply our pressure to our to this side. So I'm going to go ahead, I'm going to turn this thing on, I'm going to get it smoking. Maybe. Oh, there we go. We got some smoke. Good. All right, so I'm going to apply smoke into our purge. So this is just like if you guys were under the hood, pull the hose off the purge solenoid that goes to the back of the vehicle and apply it into our purge port on the canister, and we should start to see smoke pouring into this system. But as fast as we're pouring it in, it is coming out of our air drain, our pressure relief drain right there. All right, and let's just take a look at our pressures on both sides. All right, so if you want to smoke test this system, you need to close off the air drain. You need to seal the air drain so you can build some pressure inside of here. Again, only using an EVAP qualified smoke machine. Please do not use a high pressure system. You will ruin these canisters, and these canisters are not cheap. All right, so I'm going to go ahead and I'm going to close this guy off. And now we are smoking the entire system. So we're going through the purge line right here under the hood, and we will have smoke coming out of our gas cap right here, okay? I don't know if you guys can maybe see it. It's very, very faint right now. Maybe. Well, you'll just have to trust me on it. I got smoke coming out of the filler neck there. You can see the gas tank is starting to get cloudy inside as we're filling it up with smoke. So, case in point here, guys, the entire point of this demonstration is to show you can smoke test these systems, okay? You can go through the purge port, you block off your air drain, verify, please verify that you have smoke coming out of the filler neck. Don't get burned like that Grand Am that I had in the last Tech Connect episode. Verify you have smoke through the system, and you will be able to see and check this thing for leaks, okay? If you're using vacuum to check it for leaks, if you're jumping the purge solenoid using a vacuum pump, something like that, make sure that you plug off your vacuum drain, okay? 2 different drains that need to be closed in order to test this system accurately, okay? So I think that's going to be it for this little demo right here. I can't think of anything else on it for the moment, so I'm going to go ahead and kill the power to it, and let's bring you guys back over here. Something like that. Okay. So that is the early non-intrusive split system. Now I have the system on this car. So let's look at some stuff real world with a lab scope, because that's what we like to do, right? That's what I like to do. Let's look at how this system operates and see what it's reading currently. All right, I'm actually going to grab all the comments from you guys quick because I had that problem with the comments getting deleted. I'm going to grab them to make sure I get them all. I would hate to have them deleted again. All right, so we're getting the scope loaded up right now. Let's just see if you guys have any questions right now. All right, it looks like a lot of you guys are having to go back from, from your lunch break. Well, fortunately, guys, this is going to be, this is recorded or will be a recorded video afterwards, so you will be able to come back and finish it up. Just make sure those comments copied and pasted. Beautiful. I don't want to lose anything from you guys. Alrighty, let's look at the scope here, and let's get some stuff set up. Now, I'll bring you guys in on the system here. Bear with me. Let's make sure I don't don't make anybody sick moving a camera like this, but I'll show you guys where this thing is located. Bump into a bunch of stuff. All right, so let's take a look here. Try and get you guys all focused in. All right, there we go. So it's very, very difficult to see right now because of our air box and everything in the way. But, oh, I'm going to trip over the cords and move you guys. Sorry, hang on. All right, so right here, where our yellow lead is right here, this guy is our purge solenoid, okay? Simple looking, one hose up to our intake manifold, one hose back to our canister. This guy down here, where our other yellow lead is, right here, that is going to be our bypass VSV, okay? That's going to be what's going to change us from our tank side to our canister side. And then up here, zoom this, or bring this back a little bit. You guys can see there up at the top of the screen. Let me see if I can, there we go. You can see my blue lead there. That is your fuel tank pressure sensor right in here, okay? See if this helps at all. Does that help? That makes it worse for you guys. All right, so those are where the components that we're going to be testing are located. Why don't we first take a look at them with the scan tool? All right, so I have the scan tool here on the table. For those of you guys that aren't familiar, this is the new, or I don't know if it's new, but it's new for us, Launchpad 2, made by Launch. The people at Launch USA were nice enough to send me this thing out to play with and show you guys how I'm going to use it. It's nice too because I'm able to take it HDMI direct into the switcher so you guys can see it really crystal clear. It is a great tool so far. I've had it for a few weeks now. I've noticed that it is much, much faster than our vintage old Snap-on tool. But that's comparing, it's comparing a smart car to a supercar at this point. That thing is our Snap-on tool is so old. So this thing is very fast. What I like about it so far is the fact that you don't have to buy a European upgrade for it. You can see from day one here, we have all of these different models to play with, okay? I don't have to spend extra money on a European package. I also like that it is Android-based, so it's really easy to take pictures and transfer pictures. I downloaded myself a unit converter because I'm no scientist. I don't know millimeters of HG in comparison to inches of water and that kind of thing. So it is a slick tool if you guys are looking for a new scan tool to get your hands on. So I do have the key on inside of this Toyota. I'm just going to go VIN scan and see if I can pull this thing up through auto VIN. And I'm going to get the scope hooked up while I'm talking here. So I'm going to hook in. I'm going to look at 3 different channels. I'm going to be looking at the control for our bypass solenoid. I'm going to look at the control for the purge solenoid. And we are going to be looking at the fuel tank pressure, or the VPS, which is fuel tank pressure. What's nice, guys, what I like about these Toyota systems is the fact that our fuel tank pressure sensor is under the hood on here, okay? That's awesome. I love it. I love it. Makes it very easy to get to. I don't have to even go to the PCM on this one. I don't have to pull the tank to do it. Right under the hood. Slick stuff. All right, so channel 1 on our scope we'll use for fuel tank pressure. We will use channel 3 for purge, and let's use channel 2 for our bypass. All right, so that's all hooked up. Our scope is hooked up. Our scan tool looks like it did not auto pull the VIN, so let's just go through it real quick. Let me make sure I have the key turned on, because it's going to be hard to do anything unless the key is on. All right, key is on, beautiful. Do 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 do. Do, 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 do. This is not a typical representation of the speed of this scan tool. Old Toyota like this communicates very slowly. This is not a good example for demonstrating this tool's speed, okay? right, let me take a look while this is loading. Let's see what you guys have for comments. Looks like Arbez Auto is sharing my secret there about the AC in the shop. We recently got AC installed maybe a month ago or so now, and it's wonderful. It is wonderful. All right, so we are loaded up. Let's do an automatic search. We're going to pull Camry, 1997, 4-cylinder, perfect. Let's do system select. We'll go into powertrain, engine, entering the system. And we will start with, let's look at some data. Keith is coming on. Toyota sucks on any tool. All right, so it is not the launch tool that is being slow. It is Toyota and their computer and just how fast they communicate. All right, let's take a look. I don't really care to see the entire data stream. Let's see, they do have an EVAP specific one. Let's do a manual select. Oh, there's not much in there. Let's see what there's in all data. All data. Not all data, but all data. Also, guys, the reason why I'm using the launch tool on this vehicle instead of the Snap-on, I have the Snap-on one hooked up to our Avalon back there. The reason we're using the launch tool on this one, the Snap-on one on that one, is because they give us different things, okay? The Snap-on tool, our Veris, was not able to command our solenoids on this vehicle, on our Camry, and our launch tool was. And then vice versa, our launch tool was unable to run an automated test for the EVAP system on our Avalon, which we'll be getting into, and our Snap-on one was. So if you have multiple scan tools, I'm sure you guys have run into this quite often. Being that we've just recently gotten a second scan tool, this is the first I've seen of it, and I'm sure there will be more instances of this. So let's take a peek at our data PIDs here and see what we can grab that's going to be related. EVAP monitor, we'll grab those. VSV. Keep scrolling here, see what else they label out for EVAP. We got a purge VSV, I'll grab that. Vapor pressure VSV. And I think that looks good. We'll confirm and see what we've got. Looks like Glenn here noticed I was humming some Jeopardy music. Hopefully we don't want to get any sort of copyright for that one. All right, so our EVAP monitor looks like it's been passed. Our EVAP VSV is currently off. Purge is closed. Vapor VSV is off. And our vapor pressure right now is reading a negative 0.1232. So we're not reading zero pressure, right? We are reading vacuum inside of our tank. And the reason for that is because the system is passing and it does not have a leak currently, okay? But one thing I want to show you guys, we'll start with this vapor pressure VSV right here says that it's off, right? But is it? Is it really? Let's look at channel 2. Let's take a peek at channel 2 of our scope. I'm going to go ahead and turn the scope on, channel 2. And we are reading currently 12 volts on there. And let's take a look. What should we expect to see there? We are currently on the ground side for that. So if this solenoid were on right now, we would expect to see low voltage, ground voltage. So it does look like this is accurate in that it is off, which doesn't seem to quite make sense, but let's take a peek here. Plugged in, good connection. All right, so what side are we currently reading? That is the question. We're currently reading a negative 0.1232 on our scan tool. All right, so negative 0.1241 0.47 or so on our scan tool. On our scope, let's zoom in on our scope now and take a look at our blue line is going to be our voltage for our fuel tank pressure sensor, our VPS, or whatever you want to call it. All right, so currently we are sitting at, call it 2.578 volts, okay? So it looks like we are slightly in vacuum. Now, let's see what happens when I pull the gas cap on this system, okay? So let's take a look at our, okay, we got our scope up on the screen, so we should see a voltage change if we are currently measuring the tank side. But according to the scan tool, it says we are off, which means we should be measuring the canister side. All right, I heard some relief when I pulled the gas cap off, so it most likely went back to atmospheric, and it doesn't look like this moved at all. We're still at the same voltage, roughly, and if we look back at our scan tool, we are still at the 0.1232. So that means that we are measuring, currently, we are measuring the canister side of our system is currently in vacuum. Now, let's back out of here and let's grab some special functions and let's drive this thing. Actually, we'll go actuation test. Let's drive our bypass solenoid, and we should now see a change from vacuum to atmospheric, which is telling me that our system is switching to either half, reading either half, and I just pulled the gas cap off, so we should read atmospheric back there and vacuum at the front. As soon as this loads, all right, there we go, and we're going to run the vapor pressure VSV. All right. Suppose if I want to go in there, I should click yes instead of no. Come on. All right, I'm going to grab some monitoring data. I'm just going to go ahead and grab the vapor pressure. That's all I really care about at this point. All right, so currently, vapor pressure VSV says it's on. All right, so that seems kind of odd, right? It says that it's on. The other PID said that it was off. Which side are we measuring? Well, we're in vacuum right now and I have the gas cap off, so we know we're not measuring the fuel tank side. So I'm going to go ahead and turn this off. Okay. Now I'm going to turn it on. All right, I just heard it click. Our scope just went ground. Go ahead and pause it here. So our scope just went to ground. All right, I paused the scope. We're at ground, and we changed. So, all right, let's go back to the scan tool. I want to show you guys this thing can be tricky, okay? All right, so it says that we're off right now, which off would mean we're measuring the canister side, which makes sense. We have vacuum. So if we turn this thing on, all right, as soon as I push the on button, we're going to be measuring the tank side. Now watch this very closely. Tank side, we go up to right around 0. Still says we're on. Why did we change? Okay, the scan tool is only commanding our bypass solenoid on for a very short amount of time. Let's call it a few seconds, right? So in this few seconds of this time, the control PID on the scan tool is not switching back to the off position. So don't get burned on this with your scan tools, guys. Make sure you have a good idea of what you're looking at. Let's look at that same exact thing on the scope. I'm going to go ahead, let's blow up our time frame. So now we got 50 seconds on the screen. So I'm going to go ahead, I'm going to push on right now. I heard it click. Makes sense. Our fuel tank pressure went up. Our system grounded, and look at that. We're already back to where we were. The scan tool is still reporting the exact same thing. It's saying that our VSV is on, but as you guys can tell by the scope, it is currently not on. Okay? So keep that in mind when you're diagnosing these systems. If you think that you're going to click the on button, and then you're going to, if you're in the vehicle, you click the on button, you're going to run around under the hood and look at it, chances are by the time you make it back under the hood, it will have turned itself off. Now, I don't know if that is only with this scan tool or not, because I was unable to get it with the snap-on tool. So you guys out there using other tools, the Autel tools, the Bosch tools, anything else, let me know. Let me know if you guys are running into weird things like this, okay? What else could we show? Let's go ahead and let's fire this thing up. All right, so we're all fired up, and you can see when we fired this thing up right here, we grounded our bypass solenoid, then it went off, and now we have re-grounded our bypass solenoid, telling me that we are currently measuring on the tank side of the system, which makes sense that we're up around atmospheric voltage. All right, so when this thing is idling like this, it is watching the tank side of the system. Now, if we go ahead and if we were to jump this thing to ground, or open the circuit, I should say. See if I can unplug it. There we go. All right, so with the connector unplugged, you can see that our fuel tank pressure sensor has changed, right? Let's stop it there. Our fuel tank pressure sensor dropped down because now we are measuring the canister side with the VSV bypass valve closed. So I'm going to go ahead and start this back up, and I'll plug it back in, see if it starts working again. So the PCM is still grounding it. It must not have set a code that the computer is going to go ahead and turn it off. So let's just grab a jumper wire quick, and let's run this thing to ground, the purge solenoid to ground, and I'll show you guys what that does. All right, so I'm going to load up channel C. I'm going to put it on 20 volts. We'll grab the purge solenoid. So there we go. It actually looks like the computer's currently grounding it. All right, so it looks like the computer is currently grounding our purge solenoid. So let's turn our, I'm going to go back into the scan tool, and I'm going to go vapor pressure VSV. Oh, it might not let me command it. If you look at this notice on the screen here, it might not let me command it with the engine running. Let's find out. Let's just grab our vapor pressure again. All right, so again, it says that it's on, but we know it's not. Let's turn it on. Turn it off. All right, so it is going to let me drive it with the engine running. So there we go. We are reading vacuum. And if we look at this scope, we're definitely reading vacuum when we turn the the VSV on, okay? So there we go, our tank changes like it's supposed to, our fuel tank pressure changes, and that's the way that works. Now this thing is not going to run a leak test with it running. Okay, the leak test is performed on this thing. No, I take that back. It's not that it's not running. It's not going to use the purge solenoid again to draw vacuum on the system when it's running, because like we talked about earlier, the purge solenoid will not draw vacuum on the entire system. So don't think that's how it's being checked. It's being checked by that natural buildup of vapor or pressure inside of there. Okay. So I think that's it for, I should stay out of the comments when we're live. Just Thanks for the nomination for American Idol. Must be some good singing. All right. So let's get back to our PowerPoint here. Let's talk a little bit about the intrusive split system. All right. This is the system that is used on vehicles from about the 2000 era to the 2004 era of cars and SUVs, both Toyota and Lexus. All right. The intrusive split system is going to be very, very similar to the non-intrusive system, except now there is a CCV involved. There is a vent solenoid, okay? The fuel tank pressure sensor is located not in this standalone universe of its own. It is now typically located on top of the fuel pump sending unit, so it is measuring inside of the tank. Now, this is important to note that the intrusive split system is able to pull vacuum on the entire system, okay? We're able to vacuum the system because our fuel tank pressure sensor is inside the tank. It needs to know how it's going to react and check for leaks. So what this system will do is it will close the vent solenoid, it will run vacuum, and it will figure out if there is a leak. So instead of measuring each half individually, it will measure just the tank side, or it will measure the entire system. All right, so our bypass VSV on this system is only separating the canister from the tank when it's closed. When it opens, it joins them together, okay? That is the main key with the intrusive versus non-intrusive systems. The VSV, bypass VSV, takes those two systems, and instead of them being standalone separate, it combines the two when it is opened, okay? So we test either the tank by itself, or we test the entire system from purge solenoid to fuel cap, okay? Our VP-VSV is normally closed, so in normal position it seals the fuel tank off from the canister and the purge, which makes sense. The computer is going to watch the fuel tank as the vehicle's sitting. When opened, the entire system is going to function. The CCV is closed when the system is tested for leaks. This is why it's called intrusive, because the system is changing something in order to obtain or in order to test the system. So we're changing it, we're closing the vent solenoid, and we are testing the system for leaks. Vacuum is drawn then on the entire system, just like a purge seal test. Then towards the end of the test, just like a purge seal test, that vent solenoid is opened, and our vacuum should recover back to atmospheric very quickly. If it's not, it signals that there is blockages in the system. So this is what it looks like in a good old diagram. So we have our vapor pressure sensor, our VSV switching valve. So as you guys can see here, our pressure sensor is connected directly to the top of our tank, telling me that our pressure sensor is always reading fuel tank side or entire system, okay? We are not reading the canister separate of the fuel tank anymore. This valve in here, again, is like a gate or a doorway, whatever you want to call it. When this valve is open, we combine these two systems. When it is closed, we are only looking at the fuel tank side when we're referencing our vapor pressure sensor, okay? Right here is our vacuum switching valve for CCV. This is our vent solenoid mounted on that vent line. So what's interesting about this guy right here is doing the same thing that I did over on our little setup when I put that plug into that vent line that would go to the air box, right? The CCV is doing the exact same thing on this intrusive system. It's sealing up that vacuum vent, and it is allowing the system to be drawn into a vacuum. All right. So here's our wiring diagram for this wonderful system. We have, again, a VPS, or fuel tank pressure sensor, 3 wires, basic 5 volts, ground, and again, signal. Looks like it's the exact same wire colors as the other system was. We have our purge and VSV for CCV. So our canister purge and our vent are both run on the same power source, individually grounded by the computer. And then our bypass VSV is actually on, it's on the same power source, just at a different splice, okay? So by looking at this diagram, if you're running into issues with power supplies to all 3 of the solenoids, your problem is somewhere between this splice right here and the EFI relay. If you're running into an issue for just these two, then your problem is somewhere in here, and if you're running into issues for just one with power, you could be somewhere in here, okay? So looking at a diagram, can really help narrow the system down and take a problem that seems massive for a circuit issue, you know, the entire length of the car. Well, by looking where these splices are, where these connections are, you're able to then narrow down. It's either between splice and part, or EFI relay and splice, or whatever it may be. So, all right, that's that. Let's take a look at the codes that these systems will set. Now, these codes are going to be a summary for both intrusive and non-intrusive. You get the P0440, 441, 442 will be an intrusive only, 446, and 450. Common rule of thumb with these things, if you have multiple codes in this system, diagnose them in this order. Take your 441 first, then your 446, and then your 440, okay? Normally, rule of thumb is to start with the lowest code and go from there, but these Toyota systems like to light up the Christmas tree with codes when it really could only have one problem, okay? All right, so our P0440 is a fuel tank pressure sensor reading atmospheric after 20 minutes of driving. So driving down the road, the PCM looks at the fuel tank pressure sensor. If it's at atmospheric, it's wrong, right? Our system is sealed. We should be building pressure inside of the fuel tank. The pump is running. It's getting warm. This is specifically a returnless style system, so we're not dumping hot fuel back in the tank, but the pump is running, the road is warm, the exhaust is back there. That tank will heat up and build pressure inside of it. Look at this. This is Toyota's service procedure for a P0440. I think this is hilarious. Number 2, check that the cap is a Toyota genuine part fuel tank cap. Sure, okay. Number 3, check that the cap is correctly installed. Number 4, check the fuel tank cap. You think there's issues with caps causing leak codes? The first 4 steps are all looking at the exact same thing, verifying that the cap is sealing, okay? So keep that in mind when you're looking at these things. Let's look at a 441. 441 says that it is an incorrect purge flow. The VPS, or fuel tank pressure sensor, is either reading too high or too low when the system is testing. It's basically saying that there's too much or too little vacuum inside of the canister side. These things are common for the purge VSV to be stuck open, the canister itself to leak, or a stuck VSV for the bypass solenoid, okay? Inspect these things for charcoal contamination. The early models like to break apart inside, and you would end up with charcoal kernels stuck inside of these solenoids. 446 says it is a vent control circuit fault. The PCM is going to watch our fuel tank pressure sensor for a change in pressure when we are switching the bypass solenoid from tank to canister side. Now remember, this system does not have a vent solenoid, so even though it says vent solenoid control, we don't have a vent solenoid, okay? So don't go to the parts store and ask for a vent solenoid for your 97 Camry. They are going to sell you the wrong part or look at you funny. So no vent solenoid on here. This fault is most commonly tied to a bad vapor pressure VSV, the bypass solenoid being bad. Basically what's happening here is the computer has the bypass in one position, it moves it to the other position, and it wants to see a change between the two numbers. If they change, good to go. If they don't change, then it's going to think that there's a problem with the vent solenoid control circuit, basically saying that this is the test to see if the bypass solenoid is moving, okay? That's all it's trying to do. And in theory, running down the road in this vehicle, we should see vacuum inside of the canister and pressure inside of the tank. So a quick swing of that bypass solenoid, the fuel tank pressure sensor should go from vacuum to pressure and back when you swing that thing one direction or the other. So again, with the bypass, inspect for charcoal contamination on these vehicles. Then we have a P0450. This is your standard fuel tank pressure sensor malfunction code. Verify that you are getting your powers and grounds, possible sensor failure or wiring issue This will set a code if the fuel tank pressure sensor is under 0.5 volt or above 4.5 volts. Now, the unique part of this on Toyotas is the fact that most Toyotas will not give you a voltage pid inside of the scan tool. You will need to get out your meter or lab scope and check that voltage pid or voltage information yourself, unless you know that 0.5 volts or under is equivalent to X amount of pressure and 4.5 volts or over is equivalent to another pressure reading. Unless you know that, you will have to check the voltage yourself. All right, so then we have our intrusive system with the 440 and 442. This is your basic purge test. The purge is open, the vent is closed, the entire system draws vacuum. If the entire system bleeds up very quickly, you get a P0440. If it is a slow leak, you get a P0442. These things are common, again, to hose issue, damage and wear, and, of course, solenoid failures due to charcoal contamination. The intrusive system also can set a 451. This is the VPS sensor range performance. The PCM is seeing an extreme amount of change when there shouldn't be. So this is going to be checked when the vehicle is idling and the bypass is off. The VPS reads more pressure, so our fuel tank pressure is reading more pressure than the mechanical bleed-off valves are supposed to work. So this thing is testing and saying that it's a rationality check. It's checking for an erroneous, completely false number on our fuel tank pressure sensor. Again, we're idling, the tank is sealed, the pressure should increase, but we should not have an extreme increase. It's possible you could see a 451 code if you have a plugged up pressure relief bleed-off valve. If it's plugged up, you could potentially build a ton of pressure inside of there, but it's unlikely. Most commonly, this is just the rationality check for the fuel tank pressure sensor. This is what it is going to look like when it's running the test. So our VSV for EVAP is our purge. We're going to take that and we're going to have that closed. All right. It's important to note here that our VSV for pressure switching, right here, this guy, this is our bypass. We are closed. All right. So that's telling me that our pressure generation in here, we are measuring inside of our fuel tank right now. So our fuel tank pressure should increase because the fuel pump's running. We're going down the road, the exhaust is warm. We should build pressure inside of the tank, no matter if we're purging or not, okay? All right, and then what we do, we will then close our, we will then open our bypass solenoid will open, and our CCV, our vent solenoid, will close. So now we are reading on the canister side of the system, and we're going to build this negative pressure inside of here, okay? If you don't build this negative pressure, you set a P0441. At this point, we want to maintain this certain level. If we bleed up very quickly, like this dotted line, we're going to be setting up P0440. If we bleed up very slowly, we're going to set that 442 code. Okay? So during this leak check, our sensor is currently measuring canister side. I take that back. Our sensor is currently measuring the entire system. Remember, this is on the intrusive system, so we're measuring the system in its entirety. Our purge solenoid gets closed, and our vent solenoid is closed. So just like a purge seal test, we are watching that over time. Then we open our vent, and we close our bypass. We should see a fast change here. We should increase our vacuum level quickly. Okay? That is how the system is going to run through a leak test on an intrusive system. So, deep breath here. That was a lot of information on the split purge system, intrusive or non-intrusive. But the bottom line here, guys, what you guys need to know when you have a Toyota coming into your shop, most failures happen in the canister assembly or the purge solenoid, okay? That is where most of your failures are going to occur. Now, most of the time, the canister is going to come as an assembly. You'll get, this whole thing, which is including of the bypass solenoid. So a lot of the time, a canister will fix the vehicle. Now, I'm not saying every Toyota with an EVAP code that comes in should get a canister. I'm just saying if you're playing the odds, canisters are common for solenoid failure as well as the charcoal becoming loose inside. So sometimes you can replace the bypass solenoid separately. Sometimes you can't. Also, some of the canisters will come with the fuel tank pressure sensor. The canister that we have over here actually comes with the fuel tank pressure sensor. Some vehicles you can get it separate. Some vehicles you have to buy the canister, okay? So it's all going to matter on where you're buying your parts from and who has them. We sell them typically both ways, okay? Purge solenoid is a purge solenoid. You know, that's just basic, open, closed, pulse width driven, of course, but open and closed, tested as you normally would test any other purge solenoid. Remember, the non-intrusive system can be smoked. Block your pressure drain that's going to be down by the canister. Block that off so you can build enough smoke pressure inside of the system. Check to make sure that you're getting smoke out by your, pull your cap off, make sure you're getting smoke out of there. But your purge solenoid will not draw vacuum on the entire system on a non-intrusive style, so 96 to the 2000 era, roughly. Just smoke them like normal through the purge solenoid or however you want to do it. You could go through the filler cap too, I suppose. Our intrusive system, test it out like you would a normal purge seal. Open the purge solenoid, close the vent solenoid. When smoking, when you smoke the system, make sure that your vapor pressure VSV is open, okay? That's going to take the system from being in two pieces to combining it as an entirety. So when you smoke it, make sure you open that up, and then you close your CCV either electronically or with a vice grip or some sort of way to close it, and verify that you have smoke traveling through the entire system, of course. Or if you're using, you know, that CO2 tester, that bullseye leak detection kit, which I've actually gotten my hands on. Haven't been able to play with it yet. I've been very, very busy shooting some of these other videos that we're doing. But I'm hoping to do a demo video using that bullseye leak detection system as well. All right. Now, guys, I originally wanted to get into the vacuum pump key off system today as well. As you can see, it is up on the screen here. I wanted to cover it as well with this Avalon that's sitting behind me. But honestly, guys, I've been up here already for an hour and 15 minutes. I probably, if I had to guess, have another hour or so just on the vacuum pump system alone. So I think we're going to have to do a part 2 on this one. I think there was just so much information here that in order to cover this the right way, in order to give you guys as much of the information that I gathered in my research, in order to give that all to you efficiently, I think we're going to have to do this one as a part 2. So if you guys were here today specifically for the vacuum pump system, I'm sorry. You're going to have to come back in August. Fortunately, you're not going to have to wait too long. Our class is the first week in August. I want to say August 3rd. Don't quote me on that. Let's check the calendar. Yes, August 3rd. So it's only 3 weeks away. You're not going to have to wait as long between classes like this past one. But we will be doing the vacuum pump key-off system in the next one. We will be demoing it on that Avalon. And who knows, maybe I'll bring something even newer in than that one just so we can play with that as well. Okay, I think I've covered everything I wanted to cover. Let's see what you guys are saying. Glenn asks here, what is the easiest way to tell if you're dealing with a non-intrusive or intrusive system without getting under the car? What I would do, I would be looking at the wiring diagram. You know, pull up a wiring diagram, see if you have a CCV. If you have a CCV or vent solenoid, then you have a intrusive system. If you don't have a CCV, then you don't. You could also go into scanner data or special functions, see if you can drive a CCV, see if you have a PID for a CCV. If you don't, then you don't have it. Well, if you don't, it's possible that the scan tool's not telling you that you do have it or not. Don't trust the scan tool if it's not there. If it's there and you can control it, well then obviously you know it's there. If it's not there, well that could be because it's not in the vehicle or because it's not in the scan tool, okay? Be careful. He asked what did I miss, and Glenn is nice enough to tell him that I was singing Jeopardy show tunes, so thank you. Mike says he used to check the cap first, then move on to other diagnostics from there. Sometimes known good parts, aka a good cap will fix the problem. You're right. A quick cap check is always a good first thing. It's super simple, but like I talked about in the last class, you don't want to do that as your first thing before you verify if there's a leak or not, because then it's going to be difficult to prove out if it was the cap or not, unless you pull the thing off and the O-ring is gone or deteriorated or whatever that may be. Toyota emission warranty 100K. I don't know if they are 100K on emissions or if they are 880. I can look into that. I will look into that and find out if their emission systems are warranted to 100,000. They might be 10-100, they might be 880. Not 100% certain on that. Okay, guys, I'm going to give you guys a few minutes here to just, I'm going to open this up to any questions. Is there anything you want to see with the demo system over here, with the smoke machine, the voltmeter, anything that you want to see over there, either running vacuum or pressure on the system? Is there anything that you want to see on this wonderful 97 Camry with the lab scope or with the smoke machine or anything like that? Is there anything that I've missed that you guys want to know the answer to before we finish this class up today? Let us see. I'm just going to scroll through the comments because we have a little bit of a delay from the time I say it to the time that you guys are able to comment in. All right, looks like a lot of people had to head back to work. Well, it's good to see that you guys are busy at work, that you have to head back. That's always good. It's better than sitting around all day. A lot of comments from you guys today. Remember to give this video a thumbs up if you haven't. He deserves it. Well, thank you. I appreciate that that comment right there. Thank you. Give me the good old thumbs up on the video. That is awesome. Arbez Auto here says that the sound is very low. I'll look into changing that for the next class. I'll try and up that a little bit. Let's see here. Let's go back to the bottom and see if you guys need or want to see anything else. Oh, hang on. Saw something up here. Ah, look at this. All right. Because this has been done here, I will call it out. Actually, I got to say, no one has a petrol plow truck, really. People do. There's plenty of people, especially here in the good old state of Wisconsin, that people are using regular gas in their plow truck. All right, this right here, guys, I wasn't going to draw any attention to this because that's not the goal here. My goal isn't, be careful how I say this. The goal of this training, guys, is to train you guys and support the product that we manufacture and sell. That is why I'm up here training you guys. The goal of this is never to go out and earn a living off of YouTube, okay? This New Level Auto right here, this is called a super chat or a super comment. He donated us $1 here. So I want to say thank you. I really, really appreciate it, Keith, for the donation, but by no means do I want you guys to be going out and doing this. That's not what I'm here for. I'm here for you guys. I'm here to give you guys the training that you deserve because, you know, I've been in the shop. I have been there. It's sometimes hard to get away for a 3-hour training class in the evening, hard to get away from your family. You know, you're working full time and then you're expected to go to training class in the evening. Maybe the shop will pay for it, maybe they won't. That's why we offer this to you guys for free as a recorded video. You can go back and you can check it out anytime. I think that's probably the number one, my favorite part about it is that even though I covered a ton of information here today, guys, if you were sitting in a 3-hour class, you maybe got a book with it, but what are the odds that you're going to remember everything that that guy said? And what are the odds that you're going to get a non-intrusive Toyota system in tomorrow, where you're going to use all this information that's fresh. What's nice about this is the fact that when you get that Toyota system in, that non-intrusive system, and you remember that you attended a class that Wells did out here on YouTube, just go back to YouTube, search for it, get a quick refresher on it. The video stays up there. It will be up there tomorrow. It'll be up there in a year. It'll be up there 5 years from now, okay? You can always go back and check out exactly what I said, word for word, with the system, okay? So I'm out here to help you guys out. We're out here to train you guys and give you guys the information and training that you deserve, because I don't want anybody out there guessing and not testing, okay? We don't want to be loading up the parts shotgun and aiming it and, you know, throwing a purge solenoid, a VPS or fuel tank pressure sensor, a canister, and then still not fixing it all because it had a short to ground in a wire or something, okay? We want to be testing, not guessing. So, all right. All right. So, what else we got here? So, Ivan gave Keith the $1, so maybe I should thank Ivan. And if you guys haven't checked out Ivan's stuff or Keith's stuff or any of the guys' stuff, I mean, a lot of you guys that are on here all have your own channels. I really appreciate you coming out and watching. Ozstar, check out his videos. Keith at New Level Auto is doing some videos. Ivan at, I'm going to get it wrong here, Pine Hollow Diagnostics. Don't quote me on that, but Ivan has a channel already also. So, and of course Eric O. These guys are all great training, and they offer some really, really awesome, insightful stuff. So I appreciate you guys being out there and watching me, and when I get the chance, I make sure to get out there and watch you guys as well. All right, I think I've talked enough. Next class, again, we're going to be on that Avalon. We're going to be talking about the leak pump systems, or this big unit in particular will be the demo for next month, August 3rd. I'm hoping to see a bunch of you guys at Automechanica. Again, if you want to win those $50 Amazon gift cards, one of 3 that are going to be given away, you need to get in contact with me either before or during and meet me up somewhere, take a selfie with me, and you will be entered in. You have to be wearing your Wells Tech shirt though. So if you haven't already gotten a Wells Tech shirt, you better answer this question right so you get it in time. All right, that is at the end of the month. If you haven't already, make sure to get out there to that Automechanica website. I think you can find it through Motor Magazine's website. It's going to be a great event. I'm super excited to go, and I'm super excited to meet a lot of you guys in person. So, all right, I think that is going to be it, guys. I really appreciate you sticking with me. I hope in the beginning of class, Arbez Auto said that he was hoping to pick up one thing. I hope everybody picked up at least one thing. And if you picked up more than one thing and you're going to forget the rest of them, come back and check out the video at a later date. All right, guys, that's going to be it for me. We'll see you on August 3rd. We'll be doing the Tech Connect video the Friday before, where I definitely take a look at all these comments from you guys. So I really appreciate you being there. Hope to see you guys at Automechanica, and if not, we'll catch you back here live on August 3rd. Have a great week, everybody. Happy wrenching.